Now it's time to talk about one of the most basic and important concepts in electricity, electrical resistance. Resistance is the ability of a material to impede or resist the flow of electrons through it. The resistance of a material depends on its internal structure, so different materials exhibit different resistance values. Imagine two different roads. One is pristine with wide, beautiful streets and is a pleasure to drive in. The other spikes your blood pressure just at the thought of its narrow streets full of potholes. Which road do you think would give drivers a tougher time? The narrow, bumpy road is probably going to slow drivers down and create traffic jams, so we can say that this road has a high resistance of cars flow. In contrast, the wide and smooth road will let cars go through it freely, so we can say that this road offers low resistance to traffic flow. All materials have resistance properties that fit somewhere in the spectrum of very low resistance, like the smooth road, and very high resistance, like the bumpy road. Materials that have low resistance properties are called conductors because they easily conduct electrons. Metals are the most widely used conductors. Materials that have high resistance properties are called insulators because they form an insulated barrier for electrons to flow. A great insulator is rubber. Some materials have conductive properties under certain conditions and are insulators under other conditions. These are called semiconductors and are discussed in electronic circuit courses. Electrons can flow freely in conductors. Components that have a small resistance will have a high current flowing through it for a given voltage. High currents result in many collisions among electrons. Just imagine a high volume of cars moving fast in all directions. Every time a collision occurs, a little bit of heat is released due to friction, just like your hand rubbing the table. When the current is high enough, the material will heat up to the point that it will start burning. This is how light bulbs convert electrical energy into light. The metal filaments of the bulb are very low resistance. Because of this, a very high current flows and heats up the material to the point that it starts glowing. Don't try this at home, but if you ever touch the light bulb by mistake that had been on for a while, you're very likely to burn your hand. Ouch! Now you know why this happens. High currents can destroy a circuit. This is where fuses come into play. Fuses are components that are connected in series in circuits to break a connection. Just like when a switch is flipped off, when a current higher than expected is sensed. Suppose you have a light bulb that can only take 1 amp of current. Anything above 1 amp will generate too much heat and the light bulb will burn. As protection, you can connect a 1 amp fuse in series to the light bulb. If the current, for any reason, reaches 1 amp, then the fuse breaks, the circuit opens, and no current can flow. The fuse needs to be replaced for the system to function again, but at least the rest of the circuit is not damaged and fuses are cheap. Human flesh is also a good conductor. For this reason, you can be electrocuted if you touch a high current source. Insulators like rubber gloves and shoes are used in labs for handling dangerous electric sources to prevent the flow of electrons from the source to the human body. Resistors are components designed to implement electrical resistance in a circuit. The unit of resistance is the ohm, named after the German physicist who derived the relationship between voltage, current, and resistance. The letter used for ohms is omega, and the symbol for a resistor is a zigzag line, as shown here.